When we're trying to find an answer to a question whether there are gender differences in a test performance, first, when looking at the data, we can already tell that variable gender and variable test scores, all three of them, can help us find the answer. We can plot the scores to see how they spread. And since we're interested in the gender differences, we can add the contrast like this as well. So now it starts looking like a confetti. Let's focus on one score to begin with. Let's say math score. And let's add a little bit of contrast so that we see the gender differences. Now, if we assume that our scores are on the y-axis and we plot the means to these clouds of dots, it kind of looks like one cloud is a little bit higher than the other. But actually, it's really difficult to say. For human eye, this kind of representation will be nicer. And if we look at this means, we already might think of it that there is a difference. Statistical program will tell us whether this difference is significant or not. What's important to remember is that the statistical program that will be calculating the p-value actually will be operating with these clouds of dots. So how is this different from the paired sample t-test? From the conceptual perspective, it's not, but this time the data structure is different, and so will be the Excel buttons that we will be using, because now we are working with independent samples. So let's roll back for a second. With the paired sample t-test, we had one person, and this person answered two questions. Question 1 or question 2, question A or question B, or maybe the same question at two different points in time. What we then did, we compared these two questions and looked whether there are differences between the scores. Now, when we're comparing independent samples, we have two people, and they both answered the same question. Well, actually, we have two groups of people, and they both answered the same question. What we're then doing is comparing group A to group B. It could even be that we have a third group, and we want to compare all the groups to each other. Now, when we work with the independent samples, the important thing to remember is that the groups are independent. It's different people. And these people cannot be in the same group, at two groups at the same time. You can be either in one group or in the other. What does it mean? Well, you can either be a cat or a dog. You can either be married or not. You can either be male or female, though this one's a little blurry these days. When we want to compare two independent groups, we will be using independent sample t-test. When we have 3 or more groups and we want to compare all of them, we will be using an ANOVA.